All right, and welcome to our unit on periodic functions. What we mean by periodic functions are functions that are going to repeat themselves over and over again. They're typically written in our unit. We're going to be dealing with sine and cosine functions. So let's just take a look at a Ferris wheel. A Ferris wheel repeats itself. It starts at the bottom, goes around, and comes back to the bottom. And in this case, we have it doing that every 30 minutes, and it's 450 feet tall. So what does that mean when we graph it? Well, the first thing it means is every 30 minutes, it's going to back down to 0, right? So it's 60 minutes, it's back down to 0. Because we know that's where we're going to get on, we're going to come back and get off at 30. So that means 15 minutes in, we're probably going to be 450 feet in the air. The same thing at 45 minutes in. We're going to be at the highest point. So somewhere in the first 15 minutes, we go from the bottom all the way top and then come back down again. And then in between is going to be halfway, which is 225 feet. So graphing it would look something like this. So you can take a second to sketch a copy of this graph. And the key to notice is right here, we call this a midline. This is the 225 feet. This is just the middle of the graph, and you see it's kind of symmetric over the middle of the graph. And also it just repeats this pattern. If I just kept going all day long, if this thing just kept on running, it would just go up and down all day long. So this is what we call a periodic function. And every 30 minutes it repeats. So let's say you get on 15 minutes after your parents. So we know from the previous page, the first graph looks like this. Well, if we got on 15 minutes after our parents did, what would it look like? Well, it really would just look like this. We'll just kind of go in the opposite direction. But notice, and this is kind of a key with these things, is there's really no difference between the first and second one. If I slide it over here, the only real difference is when you start. Otherwise, every single person on a Ferris wheel is going to be following the same path, they're just doing it at different times. So if you start here, your path would look like the red path. If you started, let's say, a couple minutes later over here, it would look like this. If you went halfway through, so if you were 15 minutes in, it would look like this. Now, you could also notice that you slide over here. So maybe you get on, you get off, your parents get on, but it's going to be the same thing. The graphs are going to be the same. It's an important concept to know that these graphs are going to be the same when you shift them. So if we look also, and I just mentioned on the other page, this horizontal line that I'm referring to in the bottom problem, this is what we call the midline. And it's actually graphed better on the next page. So if you take a look at this next page, what we see here is this in the middle is called the midline. The distance from here to here is called the amplitude. And the distance from here to here, how long does it take to repeat itself, is called the period. So this is basically a sine graph is what they call it. And we'll get into the sine and cosine later, so don't worry too much about that now. But the idea is it starts, comes back down, comes back to 0. How long does it take to repeat itself? So it went from 0 to 0, and there was a 0 in between here, but keep in mind, it went up and went down, back to here. It's going to go up, down, and back. So the midline of the graph that we created was 225. Why are they the same? Well, the reason they're all the same is because that's that middle bar of the Ferris wheel. So if you think about the Ferris wheel, and that was the center of the Ferris wheel, all right, the radius of that circle is going to be 225 feet. So you're going to start here, and it's going to go 225 up to here, and then up to here. But it's going to be 225 feet all the way around the circle distance to the center. The midline, we can just draw right here. So you see your graph, and then you see your midline right here, if we're thinking about a Ferris wheel. And again, that's what the idea is behind this 225. The amplitude is the distance that we're going up and down. So this would be the amplitude up and down. So again, it's not 450 feet. The amplitude is going to be 225. But it's going to be, again, the length of this right here. And it's not going to change. It's going to go up and down. And the reason it's going to stay the same is no matter when you get on the graph, we are 225 feet from the center at any given moment. And that's what that amplitude is. So hopefully that makes sense. Hopefully I make that connection. We'll do a quick problem here. So let's say you have a 100-foot tall Ferris wheel and makes revolution every 20 minutes. So I'm just going to go here and then 5, 10, 15, 20, 25, 30, 35, 40. So every 20 minutes, it makes one revolution. So it's going to start at a height of 0, and every 20 minutes, it's going to come back down to 0. So here's 0, here's 20, here's 40, 0, 0, 0. It's 100 feet tall, so halfway through, it's going to reach its peak height. So here and here, it's going to reach its peak height. And it's going to be halfway through. And what does that look like? Draw this in black. Just like this. Here's 50, here's 100. So 100-foot tall Ferris wheel, you should notice, and I'm going to draw this line right across here. This is our midline, which is equal to 50. Our amplitude that is also equal to 50. Remember, it's the distance from here, from the midline up. It's not the total height of the Ferris wheel, it's the distance from the midline up. And then our period is how long does it take to repeat. But notice it repeats every 20 minutes. I could keep writing this as long as I wanted to, but the period is just this 20 minutes that it takes to repeat itself. So practice. Make sure you can make those sketches. Good luck, and let me know if you have any questions.